Hello students, welcome to Allied Chemistry. In this video, I will deal with the redox reaction, the synopsis and the questions asked in the previous years. Students, what do you mean by redox reaction? Redox reaction involves oxidation as well as the reduction together in a given reaction. What do you mean by oxidation? Oxidation means either addition of oxygen or removal of hydrogen or removal of electrons. So what is a reduction? Reduction means a removal of oxygen or addition of hydrogen or addition of the electrons. So this is about the oxidation reduction meaning of. We can also remember like this oil rig. What is oil rig? In oil rig, OIL stand for oxidation is loss of electrons. In RIG, reduction is gain of electrons. Students, what do you mean by oxidation number or the oxidation state? It is the charged. It can be positive charge, it can be negative charge present on the atom in a molecule or ion. The oxidation state can be 0, whole number, or it can be a fraction also. Clear? During oxidation, oxidation number increases, and during reduction, oxidation number decreases. Take example, iron, metallic iron, 0 state. It can become +2, it can become +3. See the number increases, 0 to 2, 2 to 3. Oxidation number charge increases, therefore it is called as the oxidation process. See the next example, stannic +4 becomes +2, then it can become 0 state, metallic tin. Therefore 4 to 2, 2 to 1, number goes on decreases. This process is called the reduction process. Now in terms of electron, oxidation is a loss of electrons. Here iron 0 state become +2, loses how many electrons? 2 electron. Loss of electron is oxidation, correct? So you can balance the charge. This is a +2 here, this is a -2 altogether because electrons are negative charge. +2 -2 total is 0, so 0 here, right? Similarly, iron 0 becomes +3 and loses 3 electron. +3 -3 total is 0. Or iron +2 become +3 loses 1 electron. +3 and -1 is equal to +2. Okay, remember F is iron, +2 is called as the ferrous, it is known as the ferrous, and +3 is called as the ferric ion, it is known as the ferric ion. See the next example, stannic +4 gains 4 electron. Gaining of electron is called as the reduction. +4 -4 is equal to 0. Stannic can also takes 2 electrons, reduction, and becomes +2. +4 -2 is equal to +2. So charges are balanced during redox reactions. When you solve the problems, you have to remember some of the oxidation number of the elements. For example, hydrogen is +1. Where it is +1? In the hydrochloric acid, HCl. Hydrogen is +1, chloride is -1. So, some of the oxidation numbers are fixed in general compound. But the hydrogen can also have got -1 state. For example, sodium hydride. Sodium is always +1, hydride is -1. So it is hydride compound. In hydride, hydrogen is always -1. Then you have got hydrogen is equal to 0. Which case? Suppose you take hydrogen molecule. Okay. I want to calculate oxidation number of the hydrogen. So how many hydrogens are there? 2 hydrogen. Okay. Let the oxidation number of hydrogen be x. So 2x. So total charge is 0. Right? Therefore x is equal to 0. So it can be 0 also. Clear? In case of oxygen, oxygen can be -2, it can be 0 state, -1 state, -2. In general, in common compounds, oxygen is always -2, more electronegative element, one of the more electronegative element. Now, what is the example for this? Let me take hydrogen peroxide here. Sorry, let me take water molecule H2O. Hydrogen is always 1, right? Plus 1. Hydrogen is always plus 1 into 2 times. 2 hydrogens are there. Plus that of the oxygen is unknown. Let it be x. Total charge is 0 because water is neutral. So therefore x is equal to minus 2 charge. Okay. Now for oxygen can be 0 also. For example, dioxygen. So 2 oxidants and oxygen number of oxygen is 0. X, let it be x. Total is 0. Therefore x is equal to 0. Possible. These are the special one, minus 1 and minus 2. Consider hydrogen peroxide H2O2. Okay. Hydrogen 2 into plus 1. 2 into oxygen unknown x is equal to 0. So 2x is equal to minus 2. So x is equal to minus 1. So this is now the peroxide, hydrogen peroxide. Remember, in case of peroxide compound, oxygen is always minus 1. It is like this, hydrogen, oxygen, oxygen, hydrogen. Hydrogen plus 1, hydrogen is plus 1. Total plus is plus 2 charges. Therefore, oxygen minus 1 minus 1. This is called the peroxide linkage. Okay, in case of peroxide linkage, oxygen minus 1. Clear? So here it is for peroxides. Peroxide it is. Now here oxygen can also be minus half. It is in the case of superoxide. In the case of superoxide, one of the superoxide is a KO2, potassium superoxide. You know the potassium valence is always plus 1. Okay, so we'll calculate oxygen. Now potassium is plus 1, correct? Plus 2 into oxygen unknown 0. Total should be 0. Therefore, x is equal to minus half, correct? So remember, in case of superoxide, minus 1. Peroxide is minus 1. Okay? And oxygen is in general minus in most of the compounds. Clear? Consider alkali metal group. That is a group number 1 element. Group number 1 element. Lithium, potassium, sodium and rubidium all have got plus 1 charge. Alkaline earth metal, it is a group number 2, correct? So they have got plus 2 charge, magnesium plus 2, calcium plus 2. Halogen, generally it is minus 1 like Cl1, chloride, bromide, iodides and fluorides, correct? But there are exceptions here, okay? Halogen can also have the variable oxidation states, okay? So we can find out for the variable oxidation state if they give the compound. Now let us calculate oxidation number of the underlined element. Okay, potassium is always plus 1. That is manganese, let it be x. Plus 4 into oxygen in general minus 2. So total charge should be 0. So therefore x is equal to plus 7 charge. Okay, oxidation number. Calculate for chromium. 2 into potassium always plus 1. 2 chromiums are there into x unknown plus 7 into oxygen minus 2 always is equal to 0. So when you calculate this one, x is equal to plus 6 you'll get. Bromine 2 in number, let it be x 0, so x is equal to 0, right? So now we'll go for sulfuric acid. See a sulfur, we have to calculate for sulfur. Sulfur has got variable oxidation state. 2 into hydrogen is plus 1, sulfur is x, plus 4 into oxygen in general minus 2, total is 0. So therefore 2 plus x minus 8 is 0, so x is equal to plus 6. Sulfur can be plus 6. Hydrogen sulfide. 2 into hydrogen plus 1, that of the sulfur is x, total is 0. So x is equal to minus 2, possible, right? Sulfur here, let it be x, plus 2 into oxygen in general minus 2, total is 0. X is equal to plus 4. So sulfur can have variable oxidation state. Clear? Now see this one, for chromium you have to calculate in chromium pentoxide. Let it be x for chromium, plus 5 into, if I go for common oxidation state of oxygen minus 2, it is equal to 0. Therefore x is equal to 10, but this is wrong. Chromium doesn't have plus 6, okay? For chromium maximum is plus 6, which means we should know the structure of the chromium pentoxide, right? Chromium structure like this, Cr, double bond, then 4 other oxygen atoms are joined like this through peroxide linkage. Remember, oxygen of a single bond, whenever it is there, it is a peroxide linkage. It is a peroxide linkage. So minus 1 here, minus 1 charge. Minus 1 here, minus 1. Just like hydrogen peroxide. Whenever double bond oxygen is there, generally it is -2. So for chromium, let it be X. Okay. So we'll add all these together. X plus 4 into -1 charges altogether plus 1 oxygen in terms of -2. Total should be 0. So X is equal to plus 6, which is the correct one. Okay. So some oxidation number can be calculated by knowing the structures. And this structure of CrO5 is called the butterfly structure. Okay, looks like butterfly structure. Clear? Right? What do you mean by reducing agent and the oxidizing agent? See carefully. Reducing agent is one which reduces other substances but it still undergoes oxidation. What do you mean by oxidizing agent? Oxidizing agent is one which oxidizes other substances but undergoes reduction. Or reducing agent is a substance which loses electron or increases the oxidation number is a reducing agent or reductant, or a substance which gains electron or decreases the oxidation number is called the oxidizing agent, right? Let me take one example here. If I take zinc reacting with the copper sulfate CuSO4, it becomes zinc sulfate ZnSO4 plus copper. Now zinc 0 state, sulfate you know that it is a -2, the copper is a +2 charge. In zinc sulfate, sulfate is -2, zinc is +2 and copper is 0, metallic state. Here zinc 0 becomes a zinc +2, it is a oxidation reaction, oxidation number increases. Copper +2 becomes copper 0, so it is a reduction process, copper undergoes reduction. If copper undergoes reduction, it is a oxidizing agent. It is a oxidizing agent. Why it is oxidizing agent? Because copper can oxidize zinc to zinc +2. Okay, and zinc is a reducing agent. Why it is a reducing agent? It is a reducing agent because it can reduce copper +2 to copper 0 state. Reducing agent undergoes oxidation and oxidizing agent undergoes reduction. Okay, so be careful when you are solving the problem. An important topic in the redox reaction is disproportionation reaction. We study redox reaction. What is redox reaction? Generally, redox reaction means in the given reaction, one element undergoes reduction, another element undergoes oxidation, two different elements. Now, what is this disproportionate reaction? Disproportion nothing but redox reaction. What will happen? Same element undergoes both oxidation reduction. Same element undergoes oxidation and same element undergoes the reduction process. Let me take hydrogen peroxide. It is unstable, easily decomposes to give water molecule and oxygen gas. If I have to balance these 2 moles hydrogen peroxide, 2 moles of water. Now, in general, hydrogen is always +1. Hydrogen is always +1, correct? There is no change for the oxygen. Sir, there is no change of the hydrogen here. It remains the same. But you know that this is the peroxide, HOOH. Hydrogen is +1, hydrogen +1, oxygen -1, oxygen -1. Remember, in this case, oxygen is a -1 state. In case of water, oxygen is a common oxidate is -2 state. Here you calculate for oxygen, 2x is equal to 0, x is equal to 0, correct? Right? Here, -1 become, I'm speaking with respect to oxygen, oxygen and oxygen, correct? Oxygen -1 becomes -2, number decreases, reduction. Oxygen -1 becomes 0, number increases, -1 to 0. It is a increasing oxidation, means same element oxygen undergoes both oxidation as well as the reduction. Clear? Such a redox reaction called as a disproportionation reaction. Clear, students? Shall we solve the problems now? Question number 1. Oxidation number and the electronic configuration of the sulfur in the H2SO4. Okay, H2SO4. Sulfur you have to calculate. 2 into hydrogen is always +1 plus that of the sulfur, let it be x, plus 4 into oxygen is always -2, common state, so 0. So X is equal to plus 6 will get. So only one option is available with the plus 6, correct? Suppose there were two options with the plus 6 and we need to find out the electronic configuration. For that, what should we do now? Sulfur atom number is 16. Student, you must remember the atomic numbers also. Okay, sulfur is 16. So I can write 1s2, 2s2, right? 2p6, then 3s2 and 3p4. So there are 16 electrons. But sulfur is in the plus 6 state. That means you have to remove outermost 6 electron. This is the first shell, second shell, third shell, valence shell. Remove 6 electron. 2 plus 4, 6. So will remain as 1s2, 2s2 and 2p6. So there are no electron the 3s, no electron the 4, 3p, 0. So therefore answer is option number 2. Clear? Question number 2. In the conversion of Br to BrO3 minus, oxidation number of bromine changes to. So Br2 becomes BrO3 minus. Calculate for bromine. So there are two bromine atom. Oxidation number is X. Let it be totally 0 because bromine molecule X is equal to 0. Here in this case for bromine only one element X plus 3 into common oxygen state of oxygen is minus 2, but they given minus total charge here on the ion here. Minus means is minus 1 is equal to minus 1 charge. So X is equal to plus 5 will get, right? So 0 to 5. So 0 to 5 option number is 1 here. Clear? Question number 3. In the ionic equation, BiO3 minus 6H plus acidic medium, some unknown number of electrons are gained. Reduction. Gaining of electrons is reduction. And become Bi3 and water. So value of X is. What you do is you have to balance the charges here. See, let me write the equation here. BiO3 minus. Minus means minus 1. Plus 6H plus. Correct? Plus unknown X electrons are gained to give Bi3 plus and 3 water molecule, correct? Charges should be equal on both the sides. So this is minus 1 here, correct? So this is a 6 into plus 1 charge. So plus 6. Plus here, electrons are negatively charged. So it is minus 1. But unknown is X. Should be equal to this side. Bi plus 3, correct? But water is a neutral, 0 charge. Total, right? Clear? So we'll solve this one. So this is a plus 5. So this is a minus x is equal to plus 3. Therefore 5 minus 3 is equal to x. Therefore x is equal to how much? X is equal to 2. So 2 moles of electrons are required. So the option number is 2 here. Right? Question number 4. Oxidation number of iron in the complex. This is a complex. You are studying in class 12, correct? Yeah. Potassium member always plus 1 state. Iron we need to calculate. It can be 0, it can be plus 2, it can be plus 3. Right? Cyanide. Cyanides are minus 1. Remember potassium cyanide. K plus Cn minus. So if I take K4, FeCN6. Right? So potassium is 4 into plus 1 charge. That of the iron is unknown. Let it be X. Plus 6 into charge on cyanide is minus 1. Total is 0. Neutral. So therefore X is equal to 6 minus 4 is equal to plus 2. So iron exists as the ferrous plus 2 charge. So therefore option number is which one? Fourth one is the answer, right? Question number 6. Oxidation state of the iron in the brown ring complex. Brown ring complex is formed during the detection of the nitrogen confirmatory test. Brown ring test. Okay. In the complex Fe, iron complex H2O. Water is a ligand, nitrosyl is a ligand, and sulfate SO4. Okay, here, right? Clear? So we have to calculate oxidation number iron. So this is one unusual oxidation number on iron. Sulfate altogether how much? Minus 2, correct? So total charge on the complex should be plus 2. Water is the neutral, 0 charge. So iron let it be X, right? And what is this? This also unknown. Now generally we have got nitrosyl is a neutral ligand. But in case of brown ring complex, this nitrosyl is in the form of plus 1 charge. Nitrosyl plus 1. Iron is a plus 1. Unusual oxidation number. So plus 1 iron. Nitrosyl plus 1. What is the neutral? Total charge is plus 2. Remember, in the brown ring complex, iron exists as the plus 1 charge. Unusual oxidation number. Okay. So the answer is option number 3. Clear? Question number 7. Number of moles of electron required to reduce zero point 0.2 mole of dichromate to chromium 3 plus. Dichromate Cr2O7 2 minus. It gives you chromium plus 3. So here X is equal to plus 3. Easy to write. Now we'll calculate chromium here. There are 2 chromium atoms into X unknown. Plus 7 into common oxygen number is minus 2 for oxygen. Total charge is minus 2. Correct? We solve this one. X is equal to how much you'll get? Plus 6 you'll get. Okay. So plus 6 becomes how much? Plus 3. What is the difference? 3 units difference. 3 units difference are there. But how many chromiums are there? 2 chromium. Balance it 2 times. So multiply this number also by 2. How many times? 6. Correct? Right? So 6 unit difference is there. Clear? Or you can also remember like this. For 2x here, 2x it is equal to plus 12. This side 2x, 2 into chromium plus 3 is equal to how much? 6 will get. So what is the difference? 12 to 6. 6 units different. It is one and the same. Correct? For how many moles? It is 1 mole. So for 1 mole of Cr2O7 2 minus, how many electrons should be gained? Plus 12 become plus 6. Reduction. So 6 electrons are gained. So 6 electrons are required. Question is for 0.2 moles of this, 0.2 mole of Cr2O7 2 minus, how many electrons are required? So you have to cross multiply. Okay. 0.2 into 6 divided by 1, which is equal to 1.2. Clear? Right? So therefore, what is the option number? Option number is 3. Right? Clear? Like the video, share the videos, and please do subscribe YouTube channel and the Telegram app. In the Telegram app, materials are available, PU board syllabus, Kcet, J mains, and NEET. PDFs are available. Please do subscribe. Thank you for watching.